Hello, my new young and energetic physiognomy. A very warm welcome to Diksha Vedantu YouTube channel. I'm your master teacher Neha ma'am. So I'll be dealing physics subject for you. Okay. So we are great. Kaise ho? We are great and good to start. So don't worry about your physics preparation. Your Neha ma'am will be with you. Okay now. So don't worry about your physics preparation from this Saturday. Okay, this Saturday to next Saturday, I'll be covering your complete physics syllabus. That is your Neha ma'am's promise, and that will be done. Okay. So yeah, so as you know me, or let me introduce you once, that I'm your master teacher for physics subject. I'll be dealing physics and some of the history chapters also I'll be taking for you. Okay. Jai Shri Ram to all. Yeah, Jai Shri Ram. Yes, yes. Jai Bithali. Okay. So yeah, as you know, today we are going to discuss about light chapter, which is your first physics chapter. Okay. So we are little bit late, but don't worry about that. I will not leave your physics behind. Okay. We will empower the physics. So let's start today's session. Okay. Shall we start? Shall we start today's session? So experience, skills matter than age, I think, right? Okay, I have been teaching to students of 11th and 12th standard students also. I have taught physics subject, and as some of you know that we have the channel called Diksha Vedantu Kannada. There also I have taught students of 9th and 10th physics subject. So I have a teaching experience. I am fond of physics. So that will be great combination to teach you. Jai Vedantu, Jai Diksha. Yes, Tarun. Yes. Okay, how's the Josh? Let's start today's session. Okay. So don't worry about your physics. Okay, don't think that we are late. How will be physics covered? No worries. Your Neha ma'am is here to take that worry and complete for you. Right? So let me tell you what I have planned the sessions for you. As I said before, this Saturday to next Saturday, your 4 physics chapters, that is light, human eye, electricity, magnetic effects of electric current. Okay. So, yeah, let me cover my words. So, these 4 chapters will be covered. Okay. After coming Saturday to next, then I'll be focusing more on problems, numericals, PYQs. Okay. As of now, hi. Okay. So as of now, we'll be focusing on theory more, and then we'll move on to the numericals. Is that clear? Yes, you guys can see me and hear me properly, right? There's no problem in that. Okay. Let me not waste more time. Let's enter to today's session, that is light chapter. Okay. Yeah. Let's enter. Yes. Okay. So before moving ahead, a quick update. Who haven't subscribed the channel yet, just go and subscribe the channel. You will be getting great content on this channel. Yeah. I'll make the session interesting. I'll not take out of the box comedy. Comedies will be in your session, in your topics only, because that will help you to remember them. I'll be giving you tricks, tips, etc. So the sessions will be very great. Don't miss out any sessions. Okay. So yeah, I was telling about. So if you haven't subscribed the channel yet, just go and subscribe the channel. Before your 10th boards, we are going to prepare you. We are going to make you ready to crack your board examination. And also we have our Telegram channel, which you'll get the link in the description box. Just go and join the Telegram channel. Okay. So watch the video completely. If you like the session, if you like the video, then only hit that like button. Okay. Yeah. Let's enter. Yes. Okay. Okay. So let me give you the session objectives first. Okay. I'll be telling you what are the concepts covered. Okay. This is not one shot video. I have divided this light chapter into 2 sessions. Okay, we have divided this light chapters into two sessions, that is in part 1 I'll be discussing about reflection. Okay, so mainly we can classify your chapter into two parts, that is about reflection and refraction. Okay, in today's session I'll be covering reflection. Okay, yeah, so students will be able to see the phenomenon of reflection. What is this reflection? Okay, I don't believe in mugging up the points, okay, and I don't want my students to do that. Do you want to mug up the things? Yeah, tell me, or you want to understand it? Right. When you understand and study, it will stay for long, right? So yes. Okay, so as I said, physics is one of my favorite subject. So I'll be teaching my favorite subject to you, and I have a couple of years of experience in teaching, and also I have taught 11th and 12th students physics subject also. Okay, yeah. So what I said, first we'll be discussing about reflection. Then students will be able to know image formation in plane mirror. You get a point here, right? Yeah, social portions also will be coming very soon. Don't worry. Okay, don't worry, Ravi. It will be there. Okay, don't worry. Students will be able to draw the ray diagrams. Ray diagrams are very important. Most of the students get scared by ray diagrams. How to draw that, how to remember that. But don't worry, with the trick, with the explanation, I'll make you better in that. Okay? What is Tarun? Ma'am, yesterday I had science. Rachna Sagar, pre-board, I will get good marks in physics. Very good. If you will get good marks in physics, I'll be very happy. Okay. Yeah. Okay. So see here. Then after ray diagrams, the most two important formulas. I have also made a video on your complete physics formula. Okay. I'll tell to upload it very soon. You'll be getting the video in which I have discussed the formulas from the light chapter and electricity, because most of the numericals come from these two chapters. I have already made that video. It will be reaching you very soon. Okay, don't worry about anything. So mirror formula, again an important formula to solve the numericals. Is the session objectives clear? Okay, so tell me, is the session objectives clear? Give me a thumbs up if you are ready to start today's session, because I want this session to be interactive. I don't want myself to be telling. You should reply, okay? So it will be fun as you said. So yeah, are you guys ready? Okay. Shall I start? Shall I proceed? Yes, ma'am, Tarun. Okay, done, Tarun. So let's enter to our today's chapter. Done. Okay, hi. Hi, Vani. Why, Jai, Mithil. Okay. Okay. So stay with the session. So don't stay with the session. See the explanation. See how I tell. If you like that, stay with me. If you're comfortable with others, no problem. It's your choice, right? Every student should be free. Wherever you get, I myself, I'll tell you, wherever you'll get the best, you can go there. Yeah, just it depends upon the students, and two students that whom they like or whom they get comfortable with. Okay, so let me start today's session without wasting much time. So what is light is my first question. Leave this light. So tell me the answer. To see the things around you, what you want. Tell me now in the chat section. Quickly, quick answers I want. Okay, let's not waste much time. Quick answers. To see the things around us, what we want. Don't tell me only light. With light, we want another thing. What is that? Tell us. Yeah. Okay. So tell me quickly. To see the things around? Yes, Tarun, very good. Light and eye. You captured the right answer. I was waiting for that eye answer. Yeah, light and eye are the two important or the two things necessary to see the things around us, right? If there is light, there is no eye, you can't see anything. And if there is light, there is no light, you can't see anything. So these two are the important basic things that are required to see anything around us. Done. So here we have a typical definition of light. What is light? Light is a type of electromagnetic radiation that allows human eye to see. Okay, human eye, there is two answers in this statement only, right? Yeah? Yeah. So there is a hidden answer in the statement only. Okay, to make the things visible. This statement they will not ask in the examination, it's just basic. Let's move forward. Okay, let's move forward. Why it's not moving? Yeah. Okay, so let me just check this. Okay, it's not working. Yeah, come here. So see here, can you guys see these things? I have a question for you. Okay, I have a question for you. See here, can you guys see things that do not emit light? Now we said that to see the things we want light, we want eye. But my question is, this chair, this plants, this pot, this carpet, wall, these things are not emitting light. Are they emitting light? Tell me the answer. Can you guys see these things? Quickly in the chat section. Can you guys see these things? Quickly, quickly. Okay. Let the sessions be quick interaction so that it will store in your mind. You can't see. Why? Is there a light problem or eye problem? You can't see these things. Oh, how is that possible? You can't see the chair in your house. You can't see the walls of your house. Can you see or not? Tell me the thing. In your house, you can see the walls or you'll just go and hit with a wall. You can see the walls, right? Yeah, Tarun, very well answered. But they undergo reflection and our eye is a mirror. Yeah, that was the answer. Yes, we can see the things, but they are not directly emitting the light to our eye. What they are doing? They are reflecting the light, right? So we can see how is it possible? It is possible by a process called as reflection. So in today's session, we will be discussing about this reflection. Okay? Yeah? Yeah. Let's move forward. Let's enter to this beautiful reflection concept. Yeah? How are the images, sceneries? They are good, no? Yeah? So see here. So just giving you how the reflection occurs. Yeah? So here there is sun. Here there are trees. How we are able to see these trees? By the process of reflection. Sunlight falls on the tree. Light get reflected back to our eye and we can see this. Okay. I'll explain you this in detail. Don't worry. Okay. Yeah. So what is reflection? So to remember reflection, I give an example for my students. Okay. Yeah. So to remember the definition of reflection, I'll give an example. Just consider a ball. You're playing with a ball. When you strike the ball on the ground, what happens to the ball? It will hit the ground and bounce off. Is that true? When you'll be playing, you'll take a ball, you'll hit it on the ground, it will get reflected. Yes? Yes or no? Got the point? Just remember that game and your reflection definition is done. Reflection is nothing but bouncing back of light ray from object is called as, it bounces back. Done. So how you will remember the definition of reflection? You must remember a ball hitting on the ground, bouncing back. Similarly, here a ray of light gets incidents on a mirror. Okay, what I said? Here a ray of light get incident on a mirror. And what we call this ray as? This ray is called as incident ray. Yeah, I hope you already know this, right? You can answer this. I said the ray which gets incident on the mirror is called as incident ray. But what is the ray that is getting here after bouncing back, after reflection? This ray is called as what? Tell me the name of that ray quickly. You already know this basic points, so I will not be teaching here. I will be asking you questions. So tell me quickly. Incident ray and reflected ray. Very well done. So this ray is called as reflected ray. Okay, you know this is very simple question. Let me ask some more questions. Okay, so what is this line? It's called as normal. I'll answer this myself. This is called as normal. Now tell me, what is the angle of incidence? Okay, so I'm asking the questions because it's the time to revise. It's not the times that I'll explain. Incident ray means the ray that gets incident. You all have already studied this. What we have to do? We have to recall the things. We have to strengthen our memory at this point, right? So tell me quickly, what is in the angle of incidence? Yeah, that's normal, right? Right, Manisha, that's normal. Very good. Now tell me, what is angle of incidence? Quickly. The angle between normal and incident ray. Yes, Tarun. This angle is called as angle of incidence. Okay? Yeah, Tamil Kitchen Diary. Angle between normal and incident. Yes, absolutely. So, in the beginning days, now you all are perfect with this. But in the beginning days, initially when you are studying, most of the students get confused. They'll think this is the angle of incidence. The angle between mirror and incident ray, they'll consider to be angle of incidence, but it is wrong. What you have said, it's absolutely right. And similarly to this, we have angle of reflection, and that is nothing but the angle between normal and reflected ray. You know this, okay? I'm not stressing on those points again. Is that done? Let me cater another point here, that is laws of reflection. In 8th standard also you had this chapter, right? Reflection, refraction, you have studied it in 8th also. So there was this basics and all, right? So what is angle of reflection? Incidence. So how I recommend my students to make the short notes, okay? Let me tell you about that. So are you guys, did you prepare your short notes and all? You are ready with that? Let me know, tell me in the chat. Yes, Tarun, very good. So in the short notes, you should not write this lengthy statements and all, right? So how to condense this statement? I'll write here. So angle of incidence is equal to angle of reflection. First law of reflection done. Okay, first law of reflection done. This is first law. And what is second law? Incident ray, reflected ray and normal lie in a same plane. Okay, you must make some hints, some short points. Incident ray, reflected ray, normal lie in a same plane. In this manner, you should prepare your short notes. Okay, don't write the lengthy statements in the notes. Condense them into some little points. Okay. Ma'am prepared on the day when they did lesson. Very good, Tarun. You're so smart. Okay, very quickly. The day which they did the lesson, that day only you have prepared. Very good. Okay. So let me explain. This angle of incidence and angle of reflection, both are equal. It's given by first law of reflection. And what second law states? See here, this incident ray, reflected ray. Let me explain you. See here. Let's consider this to be a incident ray and reflected ray, and here a normal. Okay, these all things, they exist on a same plane. What is meant by same plane? Let me explain you. if you consider something, some sheet, okay, if what it means, these three lines exist in a same plane. What it means, every incident ray, reflected ray and normal lies in this plane, okay, this is a plane. Is that clear? Right? So they all exist on a same plane. Shall we move further? Here there is no big deal in learning. I hope you all know this. Shall I move further? Tell me quickly. Shall I move? Is this done? Any questions here? Any doubts here? You can ask that. Okay? And also I encourage my students to ask the doubts. Okay? If you have any doubt regarding this, you can ask. Yeah. Let me proceed. So if you have any doubt anywhere, you can ask me, right? So here you can see the process of reflection. The boy can see these books. How? Because the light gets reflected. By this process, he is able to see the books. Yup. Okay, no doubt. Okay. Very good. Okay. Yes. So a beautiful example for process of reflection. I should ask this to you, but it is displayed. Fine. What is that? Our moon, Chand, right? Moon. How you are able to see the moon? Moon does not emit its own light, okay? What moon does? It takes the light from the sun and reflects to us. It takes the light from the sun and reflects to earth. So by this process, we can see reflection. Got the point? So how we can see our moon? It's by the process of reflection. So reflection process is very important. If reflection wouldn't be present, we can't see the moon. We were unable to see the things around us. So how bad it will be, right? So reflection is important. Okay, yeah. Let's jump to the properties of image. In the examination, they may ask this for a 2-mark question. Okay, this is a 2-marker question. 4 points, half of mark they'll give. 2-mark question. Okay, let me start. See here, they'll ask, write the properties of image formed by plane mirror. Okay, so what are the properties formed by plane mirror? How to write these? How to remember these lines, ma'am? If you ask me, I'll tell you the simple trick. Just imagine yourself in front of a mirror. Okay, imagine yourself in front of a mirror. The image formed inside the mirror, can you catch that image on any screen? You can't catch it, right? Okay, getting my point? How to remember the properties of image formed in plane mirror? You have to imagine yourself in front of a mirror and the image cannot be caught, so it is called as virtual image. Remember this point. The images that cannot be caught on the screen are called as virtual image. And the next point, your head will be appearing upright, right? It will not be appearing inverted. We will be erect. So the image is erect. Yeah, can we remember this? Is these points difficult? Yes, Tarun. Okay. So they are easy. We can remember. Our image formed is erect. That is 1 point. Size of image is equal to size of object. When you keep a mirror, what is your size? That will be the size of image in the mirror. It will not be appearing fat or thin or anything. It will be of same size, right? And also image distance is same as object distance. What is meant? What is meant by this? So when you move towards the mirror, what happens? Your image also move towards you. So what is happening to the distance? Distance is same. It's easy. Absolutely, it's easy. Right? Laterally inverted. What is meant by laterally inverted? You can see this boy wearing the t-shirt of physics. Physics is written over here. But how it is appearing here? It's laterally inverted. It is just reflection. It's just turned this way. Lateral, okay? Vertical inversion is different. lateral is this way, okay? So this is easy. So as I said, if you are worrying with this question, just imagine yourself in front of mirror and write this 4 points, okay? Anywhere, any confusion, any difficulty with your physics subject, you can reach out to your Neha ma'am, okay? Yeah, let me move forward. It's ulta. Yeah, but horizontally ulta, not vertical. Okay, yeah. So here I have a comparison between real and virtual image just for your information. So let me start. What is a real image? What is a real image? Light rays actually meet. So you know, after reflection, so I will consider here an object, here a mirror, and the rays getting, okay, converging somewhat will take where two rays meet, right? We call at this point image will be formed. So to form, for the formation, remember this point, okay? It's very important. For the formation of image, at least there must be two rays meeting, actually meeting, or appears to be meeting. What appears to be means? See here, if you consider a plane mirror, okay, the rays do not meet. But when we extend them backward, they meet at a point, okay? When we are extend them backward, they meet at a point. This point is called, at this point, we get a virtual image. Real image, image which can be caught on the screen, right? So you can see that, caught on the screen. And these real images will be inverted. They are not erect. They are inverted images, but virtual images are erect. They don't actually meet. So remember these points. And they can be caught. They cannot be. So what it is written? They can be caught on the screen. No. They cannot be. Okay? They cannot be caught on the screen. Okay? Sorry. Okay. So now I have a point here. See here. Example for real images, cinema screen and retina of our eyeball. When I wrote this point, I was wondering how come retina of our eyeball, it forms inverted image, because everything what we see surrounding us is not inverted, it is upright, right? We can see the things properly. Then why retina is forming inverted image? Do you guys know this reason? If you know, you can tell me. I have also gone through it and searched, I got the answer. If you know, tell me. It's given retina of our eyeball forms a real image. But why it is given as an inverted? It's not inverted. Getting my question? Yes. If you know the answer, you can tell me. Did you got this point? Did you had this doubt and cleared it? Let me know quickly. Retina is a concave mirror. Actually, it's a lens, okay? It's a convex lens. That's all fine. What I am asking is, on the retina, real image will be formed. Okay, so listen to my point. On the retina, real image will be formed and real images are inverted. Why? Our eye sees erect image. Retina is not a concave mirror. In eye, we will be having convex lens, right? In human eye chapter, you have been studying. So what's the point, you know? On the retina, inverted image will be formed. On our retina of our eyeball, inverted image will be formed, but the optic nerves that takes the image to our brain, right? So what our brain does, it again inverts the image. Yeah, that's the right answer. Ghost gaming, that's the right answer. The image goes to brain through nerve cells and it then corrects the erect image. That's the answer. Okay. Very well done. Ghost gaming. Yeah, that's the right answer. So that holds same with the cinema screen. There will be multiple lenses, mirrors and all, so they'll get changed. The erect image will be, inverted image gets erect. Okay, and example for virtual images, plane mirror and water. If you go to some water pond, water surface and see yourself, you can see your image, but you can't catch that, right? So it's an example for virtual image. Done. Let's move to some more important concepts. Okay, no worries if you haven't answered right also, no worries, feel free to answer. Okay, I'm not testing here who is right, who is wrong. Just answer whatever you know. Okay, that's all. Okay, we are here to study. We'll make mistakes, we'll correct it and we'll study. That's all fine. Okay, so entering to the important topic, that is spherical mirrors. From here you can expect most of the questions. Till now you can expect some questions, but now you'll be getting more questions. Okay, so here it's just introduction. After this we'll be dealing important concepts. So let me give you a quick introduction to our spherical mirrors. So we have two types of spherical mirrors. Yeah. Okay. So we have two types of spherical mirrors. They are concave mirror and convex mirror. Okay. So yeah, what is concave mirror? So you can see the structure of concave mirror, right? And how to remember this, ma'am? If you ask, ma'am, there is two types of mirror. How to remember which is concave, which is convex? So see here, what is cave? In concave, you can see cave, right? So cave-like structure, it's inward. Okay, so that is concave mirror. And what's convex? Opposite to that, it's like bulged one. Okay, you can consider it to be a bulged surface, or yeah. So this inward curved is concave and bulged one is convex. Okay, so you can now identify which is concave and which is convex. Now let me give you some points about them. Okay, let me give you quickly. So what is concave mirror? Its reflecting surface is curved inward, as its shape suggests. Its reflecting surface is inward, and here the reflecting surface is outward. Done. We call concave mirror as converging mirror and we call convex mirror as diverging mirror. Okay, I'm not just reading out the points here, I'll explain you that also. So why we call concave mirror as converging mirror? Okay, why do we call concave mirror as converging mirror? See here, when the light rays fall, when parallel light rays, not with different angles, when parallel light rays fall on concave mirror, after reflection, they all meet at a same point. You can see that, right? After reflection, all rays are meeting at the same point. They are converging, so we call it as converging mirror. And what's happening here? The light rays are moving apart. They are diverging. They are not coming together. They are going apart. So we call this as diverging mirror, right? And here, remember, in concave mirror, you'll see the images large sized. But in convex mirror, the image size will be small. Okay, is that clear? Yes, shall we move further? Is there any doubt, any confusion regarding this? If you have, you can ask that. If you know this, you're done with this, let's move forward. Yeah, tell me quickly. Shall I proceed? Yes, you should be telling, if you are done with this, I'll move forward. Yes, quickly, tell me, shall I proceed? Okay, there are just important concepts that we have to discuss. So let's move forward. Let's not waste more time in basic concepts. Before that, yeah, clear, Tarun? Done. Very good. So you have to answer this question, okay? All of you, okay, who are watching this video, tell me the answer. Moon morning sun is not so hot as the midday sun because, so you have the yes, ghost gaming done. Let's answer this question. Simple question, but it was in CBSE in some year. Okay, very simple question. Okay, tell the answer. So let me read out. Morning sun is not so hot as that of midday sun because sun is cooler in the morning. Is that sun is like, I'm cool in the morning, I don't want more heat, or heat rays travel slowly in the morning. Heat rays are lazy in the morning, so they'll travel slower. Is that answer? Or ma'am, it's just a God gift, we don't know, it's just God gift, you'll say. Or the sun rays travel longer distance through the atmosphere in morning. Option D, ghost gaming. Okay, I'll tell the answer, but first, who want to give the answer? Write down the answer. Ghost gaming has given the answer. Option D. Yes. Who want to guess the answer? You can guess it. Who know the answer? You can write the answer. Yeah, quickly. So many students are watching, right? 7 to 8 students are watching. So I want answer. It's option D, Tarun. Okay. Yes. Any more answers? If you will interact in the session, then only you can gain more. Okay. If you are simply watching the video, it's not that, yeah, that will be not that good. So yes, if you know, you can answer. Yeah, shall I tell the answer? Okay, then the right answer is option D. Very well done, both of you, Ghost Gaming and Tarun. Very well done. Option D is the right answer. Why? Sun travels longer distance in atmosphere in morning because our earth is geoidal shape. It's not round, right? It is more bulkier horizontal than vertical. So when sun is here, okay, in the morning, when it is here, it has to travel these long distance. Okay, this long distance it has to travel. But during afternoon, the sun is here and here the distance is small. If I write this R distance and this D distance, clearly from this diagram you can say that distance D is greater than R, right? So in the morning, the sun rays have to travel a longer distance, hence our sun is cool in comparatively to afternoon. Yeah, then shall I move? Yeah. So yes, focus here because this is extremely important concept. You can expect 1 to 5 marks from this question, okay, from this concept. So it's very important. Highly recommended topic. Because in the MCQ, they may ask any one of this, or for a 5-mark question, they may ask you to explain all of this. Getting my point? So this is important and it's not too difficult also. I'll explain you that. So to know this, to answer this question, you must have some background knowledge, some context about this. Okay, how the mirrors are made. Okay, do you guys know how mirrors are made? Let me know, tell me. Tell me quickly, do you guys know how mirrors are constructed? You know? Is it done or you know? What's the meaning? Quickly. How mirrors are constructed? Yeah? Yes, quickly. Do you guys know? Yeah, tell me. So many people will be watching, but you have to interact, okay? Let the sessions be. Yes, ma'am. So you know, right? So, yeah. Who know? That's good. Who don't know? Let me explain for them, okay? You know how the mirrors are made. They'll take completely the circular hole. It's called as hollow sphere, okay? they'll consider a hollow sphere. They are part of circle using nickel aluminium. Okay, so yeah, it's right, it's good, but it's not called as circle, it's called as sphere, right? Three-dimensional thing. Okay, if it's 2D, you'll call circle. If it's 3D, you call it as sphere. No worries if you write circle also, it's fine. Okay, no worries. Let's answer, that's all. Okay, so this is sphere. What they do, they polish the sphere, either the inner surface or the outer surface with aluminium, nickel kind of structures. They'll polish one side, they'll polish. And what they do, they cut a piece here, right? They'll cut a small slice out of that, right? After cutting the slice, what happens? You'll get a mirror here. Okay, this is your mirror. You can see, right? You got the mirror. Yeah? Is this? Yeah, this is a real channel of Vedantu. Why do you get confused about that? It's definitely 100% pure channel of Vedantu. Okay, don't worry about that. Okay. Yeah, this is English. Okay, main communication language is here, English. It's collaboration with Diksha also. So it's Diksha Vedantu. Okay, there's a collaboration between Diksha and Vedantu. So based on them, this channel is. So it's two big names, Diksha and Vedantu. Both the names are collaborated with these channel. Okay. Yeah, fine. No worry. If you don't know, you can ask that, I'll answer. Okay. Yeah, hi. Komal, hi. Okay. So I was telling about mirror construction, right? So this is mirror. Now this sphere, or you consider this to be a circle, it has a center, right? Every sphere or circle has a center. There is no question about that. That center is here called as center of curvature. Which center? So this sphere has a center. Ma'am, I joined Diksha main campus for my 11th. Okay, so good. Good. Oh, why do you? Okay. It's fine. In Bangalore, yeah, I know that. Yeah, it's good. Okay. So prepare well for your 10th board, score well and study well further, right? I just want that from my students. So that I have completed my bachelor's, okay? And I have started teaching during my bachelor's only. So I have experience from then. During my bachelor's only, I have been teaching to students and now I have completed that. Right? Okay. So center of the sphere is called as center of curvature, right? So what is center of curvature? Center of the sphere from which mirror is taken out. Done. Good. Okay. The sphere has a center. The center is nothing but center of curvature. Simple, straight, one-line definition. No more masalas. Direct one. Okay? Yeah. Next is radius of curvature. As the sphere has center, it also have a radius. You already know what is radius, what is center of the sphere and all. Okay? So the radius of the sphere is nothing but radius of curvature of the mirror. So it became rhyming. Radius of the sphere is the radius of curvature of mirror. Okay, remember like this. Done? It's defined as the radius of sphere from which mirror is taken out. Done, simple. And the next point is aperture. So what is aperture? The entire reflecting surface area of the spherical mirror. So in this example, this is our reflecting surface, this area, right? So this is called as aperture. The entire reflecting surface of our mirror. Aperture. Then we have pole. So what is pole? The midpoint. So let me show it here. I drew that. So here I told it's aperture, right? The midpoint of the aperture is called as pole. So you can see here, right? Can you guys see here? The midpoint of the aperture is called as pole. Okay. Then we have principal axis. So what's principal axis? Diameter of the spherical mirror. Yeah, but it's the reflecting surface, or also you can see the diameter of your spherical mirror. Fine. Okay, moving forward, principal axis. What's principal axis? It's just a straight line passing through the center of curvature and pole. The line that is passing through center of curvature and pole is called as principal axis. Is it done? So how? Yeah, is it done? Tell me quickly. Tell me quickly. Are you guys clear with this? So this is very important. Don't skip this topic. Okay, I'll not recommend to skip this topic because it's extremely important. Done? Yes, shall I move forward? If you have any question, any doubt, anything, you can ask that. Yeah? Okay. So, as I told, here I will be including some of the questions, okay? Here there are around 7 questions. Clear? Done. Very good. So, here I will be including some of the questions, but majority of the questions, numericals, I will be dealing later, okay? Is that fine for you all? So, in this beginning sessions, from this, as I said, from this Saturday to next Saturday, I will be covering your 4 chapters theory completely. After that, I will be solving questions, I will be dealing with numericals. So, don't worry about your physics preparation, it will be done. Okay? Yeah. Let me move forward. Moving forward, we have focus and focal length. So, what's focus in general context? Leave physics. Tell me, what is focus? People will be telling you, study with focus, right? So, what is focus? In general, tell me what is focus quickly. Yeah? Yes, what's focus? Shall I tell? Shall I tell what is focus? When people tell you study with focus, it means that avoid all the distraction. Let your focus, let your mind concentrated. Yeah, concentration. Right, Tarun? Let your mind be concentrated only on studies, except all the distractions, right? Similarly, here focus is nothing but all the light rays that fall parallelly, they meet at a point, as I said before. That point is nothing but focus. So, you can relate the normal focus with our physics focus, right? In normal general context, just avoiding everything and focusing on one thing. Here also, same, any ray that falls on this mirror, it meets, it passes through a same point. That point is nothing but focus. See here, what's the definition of focus? The point on principal axis. So, where is this point? This point is present on this principal axis. Clear? Where all the parallel rays actually meet or appear to meet after reflection. So, you know that, right? Here the process of reflection is going on. After reflection they are meeting here. So, this point is called as focus. Ma'am, how was your 12th JEE Mains paper? Was it easy or tough? There's big story about my JEE preparation. Okay, let me discuss about that in some other day because it's big story. Yeah, I was very fond of JEE. I was preparing for JEE. I was not so much concentrated towards NEET or CET that goes. I was very much craze of JEE. Okay. Yeah, it was somewhat. Okay. Yeah. What's focal length now? Right? But you should prepare and you should attend that examination. What I tell to students is, don't think that it's a tough examination, should I prepare or not. First focus on your boards, okay? Quickly study everything about your boards, okay? Initially you finish it off and then focus on JEE questions. Because what happens, right? It's if you'll qualify that, you'll get the colleges, it's all secondary. But the first thing is, when you cater that problems, when you try for that, your intelligence, your capacity will increase for definitely. Okay? Ma'am, not your JEE paper, I was asking about this year. Okay, so this year paper, yeah, the reviews were going on. I haven't checked it in detail yet. But you can go and check out other Vedantu channels for JEE. There is a channel where they are discussing the papers also, okay? They are asking the students who have attended this. And what I tell to all students, go and prepare for those kind of competitive exams. That will be surely helpful for you, okay? Yeah. Coming towards the point, what is focal length? So here, the distance between pole and focus is called as focal length. No much questions. Focus, pole, the distance between them, focal length. That's all. Done? Okay. So here we have a formula. If they ask this question, it will be for 1 or 2 mark. It's not big numerical. Relation between focal length and radius of curvature. You can draw this image in your short notes. Okay. So F is equals to R by 2. So what is this? This is R and this is your focal length. Okay. If you see this image, this is pole and this is center of curvature. Okay. From this image, you can say this R is equals to, here the distance is F and here it is small f. So what you can write finally, R is equals to 2f. You can use this formula or that formula, both are same. R is equal to 2f, f is equals to R by 2. Done. So, simple formula. Write down this formula and how we can remember it. So, R is capital R. Okay, I'll give the trick to remember this formulas also. I said, you know. So, how you can remember this? See, this R is capital R. So, R is big. F is small f. So, f is small. So, R will be equal to 2 times the focal length. By this analogy, you can remember this formula. Capital R, R is big. So, R is equals to 2f. You may get confused that R is equal to 2f or f is equals to 2r. So, from this, you will not get that confusion. Yeah, was the trick helpful? Tell me. Was the trick helpful for you? Do you guys want more this kind of tricks to remember the formulas? Yeah? Yes, quickly. Tell me in the chat. Hi, hello everybody. Right? Shall I move forward? What Tarun? Helpful. Yeah. Done. Good. Yeah? I'll move forward. If you're clear with that. I'll be giving you more those kind of tricks. Don't worry. Okay? Coming to the sign convention of spherical mirror. Now my question is, how do you remember this? How do you remember sign convention? How do you remember sign convention of spherical mirrors? Yeah. Martina Sharma, what, ma'am, how to prepare physics for CBSE board examination? Okay, so I'll be dealing, okay, you can prepare, okay, you can prepare here with me, right? So I'll be discussing everything, but also I'll make sure to bring a video on that. So I'll make a video, don't worry about that, okay? Okay, I'll make a video on how to study physics, what are the important topics. I'll bring that very soon. Okay, don't worry. So students, please concentrate on the studies, right? So I asked you guys a question. Tell me the answer quickly. Right? If you want to study well, if you want to score well, then you have to, if you want to score well, you have to study well, right? So focus here. Okay, tell me quickly, how do you remember, how do you read this sign convention? How do you read, how do you remember this sign convention quickly, or else I'll move forward. I'll move forward quickly. Can you guys tell me, how do you remember this? So let's not deviate, let's not, okay, focus on here, because you don't, let me tell you really very strictly, okay, let me tell you very strictly that you don't have much time. By applying Cartesian plane formula, absolutely right. Absolutely right. Hello, new student, who is that? Yeah, Mr. Superb Gaming. Okay, so welcome. And subscribe the channel if you haven't subscribed. Yeah, so yeah, the answer was right, by applying Cartesian plane formula. Yeah, Martina Sharma, absolutely right. By that formula, you can easily remember this. Okay, do you want to know? So listen, students, please be focused towards your studies. You don't have much time. Let's be very serious, and you have not a month also, right? So focus on your studies, get up your preparation, study well, score well, and get good marks. Yeah, so those students who don't know Cartesian formula, let me tell for them. So what is that? So to remember this sign convention, you have to just recall your mathematical graph. So what is your mathematical graph states? It has a origin here, right? It has positive x-axis, negative x-axis, positive y-axis, and negative y-axis, right? Okay, so let me tell you. So this is called as Cartesian graph. Okay, in that, anything that goes in this direction will have positive sign. Opposite to that, negative sign. That goes upward is positive, and that goes now downward is negative. Yeah, I'm continuing, right? Yeah, I'm telling that. Okay, so this is the Cartesian. So just implement this. Okay, see here. Here we have origin, here we have pole. Okay, instead of origin, we call it pole, right? Okay, so this is pole or the origin, you can call anything. So see here, distance towards right is positive. Students, is that clear? Do you guys getting my point? How to use Cartesian for the sign convention. Okay, you need not to remember these all things. You can just remember this graph. Anything that goes in this direction is positive. Opposite to that is negative, right? So see here, the one important thing you have to remember, okay? So the one important thing you have to remember is direction of light. Direction of light should be towards right. So again, it's a rhyming. Yes, students? Okay, see here, direction of light towards right. It should be always towards right. That's only clear? Yes, Tarun, good. Done. So, we'll move forward. Done? Okay. So, moving forward, yeah, listen to my point. So, what I said, for your numericals, while solving the numericals, we want this, okay? You should use this sign convention. Why? To solve the numericals, this sign convention will be helpful. They'll not directly ask in your examination why this is positive, what is negative. They'll not ask this kind of questions. But during numericals, solving the numericals, you will use this, okay. Similarly, when you solve the ray diagrams, okay, while solving the ray diagrams, you will be using this incident rays, okay. How to? Now, what are the incident rays? Simply, there are three kinds of incident rays, okay. I am not again drawing the incident rays. They are on your textbook, on your screen also you can see. So, I will give you the simple definition to remember this, okay. And another one, there's a trick, so see here, at least when you're drawing a ray diagram, at least there should be two rays and more rays are not required, okay. Okay, more rays are not required, two incident rays are well and fine. Done? So see here, first ray that is parallelly incident on your concave mirror or convex mirror, after reflection it passes through the focus. So what's the first point? Yes, what is the first point? If incident ray is parallel, after reflection it passes through focus. Done. See here, second one, it's passing through focus, okay. Incident ray is through focus, but after reflection, yeah, after reflection it will move parallel. Good, Tarun. If you are getting what I am saying, it's absolutely good. Yeah. So anything that goes to focus, after reflection it will go parallel. Here see, center of curvature, again from center of curvature, no change. So center of curvature to center of curvature. Just remember these 3 points, okay? No worries. Parallel, focus, focus, parallel, center of curvature, center of curvature. That's all. Okay? Yes, students, clear? Yeah. So, shall we move further? Okay. So, yeah, these are the standard incident rays that I have told you just now. Okay. So, we have here image formation. Students, shall we take a quick break? Tell me. Tell me, students, shall we take a quick break? After break, shall we continue? Yes? Yes, students who are watching, Tarun and yeah. Beyonce and Yef. Hi. Hi, hi, hi. No break. Don't break. Your wish. Okay, fine. If you guys don't want break, no. Okay then, I can teach. Yeah. Let's complete and then have a long break. Let's complete the session. No problem. That's fine. That's absolutely fine. Yes. Okay. So see, students, let me start you with the image formation in spherical mirrors. Okay. So these are the 6 ray diagrams you are going to get, and they are very important in your examination. They may ask you to draw the ray diagram, okay, or else they'll ask you, let's finish in one shot. Okay, no problem. Let's finish. See here, 6 ray diagrams are there, no? So they may ask you to draw the complete ray diagram, or else they'll give you this object part and they'll tell you to plot the image, okay, by drawing the rays. Any of these things you must be good with ray diagram, okay. So I'll be helping you with that. See here, let me start. First thing is, object is at infinity, okay. I'll also give you the tricks to remember. See here, when object is at infinity, any direction the rays may emit, but it's too far, it's from infinity, so the rays that reaches will be parallel. First point. So you have to remember that anything which is too far, the rays reaching from that will be parallel. And in our standard incident rays, we have studied that ray diagram 6 is important. Yes, 6th ray diagram is unique kind of ray diagram. It's different from this 5, right? So all of them are important. We'll be discussing about that. Okay, so what I said, when the object is at infinity, the rays that reaches will be parallel. And in standard ray diagrams, we have studied that parallel rays after reflection, what happens? In standard ray diagrams we have seen, right? See here, parallel incident rays pass through focus, right? So from that we can see the image here is formed at focus. Okay, object is beyond, it's at infinity and image is formed at focus. Now ma'am, is there any other trick to remember this? Yes, there is. So what is the size of image? Okay, how to remember the size? Now where are the stars present? You see the stars at night, right? Where are they present? Are they near or very far from us? Tell me the answer quickly. Yes, tell me the answer quickly. Yes. Yeah, students, answer. Yes, Diksha, Vedantu. Now tell me, are the stars near or very far? They are far. Tell me quickly. Yes, first. Are the stars near to us? From that point you have a hint here. So I am waiting. It's far from us, right? So when we are seeing that far thing, what is the size of the star? Is the star appearing in some structure or it appears just as a dot, right? As a small point it appears as. So anything that is very far at infinity, its image size will be point sized. Why? How to remember this? From the star. It is visible near because of atmospheric refraction. Yes, human eye chapter. Okay, we'll be discussing about that chapter too. Right? So, infinity, when the object is at infinity. So, here what we are doing, we are keeping the object at infinity and with the time, we are bringing it near to our mirror. Lens we'll be discussing later, but here we are discussing about mirror. Here the object was at infinity, but here it's beyond C. At C, between C and F, what's happening? We are bringing the image towards the mirror. Okay. Yeah, Aditya. Okay, so tell here. First point is clear. Is the first diagram clear to all? Tell me quickly. It's very basic. Here nothing to study. What we have studied about focus, right? Same ray diagram here. First one. Moving to the second one. From infinity, we have brought our object somewhat near. Okay. It's beyond C now. What happens when the object is placed beyond C? One ray is parallel which passes through focus. Another ray is passing through center of curvature. After reflection also, it passes through center of curvature. But the image is formed between C and F. But the object is beyond C. And what is the size of the image? Size is small. It's called as diminished. Clear? Okay, very good. Okay, there's a trick to remember this also. I'll be telling that after this. Okay, just I'm giving you some context, some explanation, so that by this you can see these images and you can capture that in your mind. Okay, while they ask the question, you should be able to draw these images. When the object is at C, image is also formed at C. This is one of the beautiful easy one diagram. Okay, why? Here the object size is same, object image distance is same, okay, and the position is also same, they are at C. Okay, tips to be smart. Just keep working. Create some, while you will be studying, no, try to find something trick to remember those things, that's all. Okay, study well, be focused, everything rest will be taken care, it will be done, okay. This is the point, this is good diagram. Moving forward, now the image is kept between C and F, okay. When the object is kept at between C and F, so we have brought it more near. Ma'am, tomorrow we have paper discussion, no ma'am? Yeah, right. It's from morning 11. Yeah, morning 11. Yes, so we'll be discussing the every subject of physics, chemistry, bio. Okay, the papers will be discussed, don't worry. We'll be discussing the sample papers and it will be definitely tomorrow morning 11. So don't miss out that. So what is the meaning of Diksha Vedantu? It's the YouTube channel in the collaboration of Diksha and Vedantu. Okay, you know Diksha, you know Vedantu. So both of them with the collaboration, we have this channel. Done? Okay. So I was telling here, right? So when the object is placed between C and F, image is formed beyond C and the image is inverted. So don't worry about the image size and all, I will be telling you. Ma'am, will Basuraj sir will come for that session? Yes, Basuraj sir will be there, Suhas sir will be there, Ankita ma'am, Navya ma'am and I. We all will be there in that session. Okay, don't worry. Why ma'am no class for 9th? Yeah, as the 10th boards are near and it's a board examination, right? So now, as of now, we are focusing this channel mainly for 10th boards. Okay, after that when your boards will be done, we may start with the 9th also. Right? Okay. So is this clear? Right. See here. Next, we are keeping the object at focus. Right? It was between C and F. Now it is at F. That's the focus. But here the rays will meet, but they will meet at infinity. Okay, clear? Good. If you are done with that. See here, what I was telling, when the object is at focus, it will not meet, it will meet, but it will meet at infinity. How long will you continue the class? It will be, so I am discussing here image formation of your concave mirror. After that, convex mirror, some of the problems done. So it will go some more within 30 minutes. Ma'am, Diksha recommended me this YouTube channel. Okay, so fine, good. And yeah, at infinity, yes, absolutely right. Very good. Okay, very good. See here, is this done? When the object is focused, image is at infinity. But here comes the special condition. Here this lines, this is a concave mirror, converging mirror. But in this last condition, when the object is placed between focus and pole, the rays do not meet itself. They'll just go like this way. They'll diverge. So what we will do, we are smart. So we trace them backward. Okay. If they are diverging, we'll not leave them like that. We will trace back them backward. So we get an image behind our mirror. So the image is beyond mirror. Yes. Right answer. Image is beyond mirror. So it's a virtual image. So till here we had a real image. Now we'll be having at the last condition virtual image. Now just let me give you the trick to remember this. Okay, before that we have convex mirror. So let's discuss this also. Yeah, I'll be telling you about the image size, position, everything. To remember everything, I'll give you a trick, okay? Don't worry about that. So discussing about the formation in convex mirror. Convex mirror is a diverging mirror, as I said before. So here the images formed are virtual. Here you will not find any real image. And also we have studied image size is diminished. Virtual and direct. Which one? Yeah. Fine. Tarun. Yes, virtual and direct images always. Okay. And also size will be diminished always here. Yes, always virtual and diminished. Yes, absolutely right. Absolutely right, Jinil Kalita, right? Absolutely right. Okay, so see here how to draw the ray diagrams. Again, object is at infinity. After reflection, focus, image will be formed. So infinity, focus, same one. Here it's somewhere, it's beyond principal axis, but not at infinity. Ma'am, we need numerical and PYQ. Yeah, I was thinking about this, those sessions also. I thought that first I'll sort out all the theory and then we'll jump to PYQ or numerical. Okay, if you want the mixture, we can do that. Okay. Martin Sharma, right? Yeah. So we can do that. I'm planning the numerical session for you. So every numerical from your physics we'll discuss one day. Okay. But before that I thought I'll complete the theory sessions of your 4 chapters from physics. After that we'll be having that marathon sessions and all. Don't worry. See here. When the object is placed here, what is happening? Image is formed between pole and focus. Okay. When object is before the mirror, it's somewhere between infinity and pole. Image is formed between P and F. Now let me come to the trick to remember this. Okay, where it went? Yeah. Sorry. No worry. Yeah. Shall I? Okay, done. So what's the trick? What's the trick I'm talking about? See, this is the table you have in your NCERT also, right? So do you guys know there is some trick with this table? Do you guys have already studied about it? Tell me. I wanted to know. Yeah, tell me quickly. Do you know the trick? Anybody? Quickly. Do you know from this table to remember the things? Yes or no? And those who don't know, for them I'll be telling here. Okay, so listen. So first you have to remember, not remember also, you have to just recall this one column. Okay, how to remember this one column? By this you can remember from your principal axis. No, okay, then fine, we'll study here. Great. Okay. Yeah, see here, this is where it went. Yeah, this is your principal axis. Okay. Yeah, so in your principal axis, here you have your pole, right? So this is pole. After pole we'll be having focus. Yeah, after that we'll be having center of curvature, and after that, yeah, we'll leave it. So first you must remember the position of your object. Object at infinity, yeah, that is written here. Object beyond C, second point. At C, third point. Between C and F, fourth point. At F, fifth. Between P and F, that is the sixth point. So by this your principal axis, you can remember this first column, right? Is this clear? But you can, when you give your examination, you can roughly draw this table so that it will help you to locate where the image should be formed. If you miss out drawing the ray diagram also, you can plot the image at the right position. So the examiner, while checking, he'll see that is the image at the right position or not. If it's there, just they'll give you the marks. Okay, this is a trick to remember that. Now this I told to remember the first column. Now how to remember second column? Yeah, how to remember the second column? Just write here 1, 2, 3, 4 and 5. This is exception case. The sixth one I am not writing there. 1, 2, 3, 4, 5. Next, what's the procedure? 5, 4, 3, 2, 1. That's all. Done. The second column is done. Ma'am, are you new in teaching field? No, I already have the experience. I used to teach from my graduation days. While studying only, I started my teaching. Yeah? Okay. So see here, 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Second column is done. So see here, 1 at infinity. Here is that at infinity. Here, beyond C, 2. Beyond C. Can you see there? The numbers, they are specifically matching. They are just inverse. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. That's all. Second table is done. And what's the third column? See here. In third column is the size of image. What I said, when you see the star, okay? When you see the star is point sized, right? It's at infinity. So what you can remember? Point sized, diminished, same size, enlarged, heavily enlarged, enlarged. So do forget this highly enlarged, okay? Just remember point sized, diminished, same size, enlarged, enlarged and enlarged. So you can remember that. Ma'am, in any school will you teach? You teach, ma'am? So I'm not teaching in any schools. I'll be teaching in online platforms like this which you are watching now. So no, I'm not teaching in any of the schools. I'll be teaching in online platforms. Okay? Yeah. So is this size clear? Point, diminished, same size, enlarged, large and all. Then moving forward, we have here realigned. So what's the nature of image, right? Yeah, what's the nature of image? As this is a, which kind of mirror? It's a concave mirror. Yeah. As it is a concave mirror, you'll always find real and always real images are inverted. And we have an exception here, that is this sixth one. Okay, I'm not discussing about this yet. Ma'am, go on numericals. Yeah, I'll be diving there. Okay, so see here, I'm just recalling, I'm giving you some tricks to remember. Okay, so see here, all the real and inverted image except this one. I hope this table is clear. Okay, if anyone if you have any confusion, you can ask that to me. Okay, yes, yeah. So similarly, here also, always the image is virtual and direct. So it's diverging mirror, so image will be virtual and virtual images are direct. Fine. Always it is small sized, that is diminished. Will not find large images in convex mirror. Okay, this is a convex mirror. Here also you can see these things, right? Yeah, numericals. Students are very excited for numericals. Okay, then here you go. Then why to wait? Okay, yeah. So this is based on your ray diagram and you have to answer the questions. If the image formed by a mirror for all the position of object placed in front of mirror is always virtual and diminished, state the type of mirror and draw the ray diagrams. So again, drawing the ray diagrams is not required. Clear, clear, clear. So answer the question. What kind of mirror we should use wherever you keep the object? Convex mirror. Yeah, done. Let's move. You are so smart. Yeah? Okay. So we have another one, application. Let me cover this quickly. Okay? Then we'll be jumping to the questions. So numericals. Sorry, before numericals, it's the application. Yeah, the refractive index, okay, if you want I'll be telling you here, but in the tomorrow I'll be taking another session of your light chapter, okay. In that I'll be dealing with refraction part of your light chapter. Again in that I'll be discussing about what is refraction, how refraction takes place, what is refractive index and all. But if you want now, I can tell you refractive index is nothing but it's just the ratio of speed of light, okay. In speed of light in vacuum is 3 into 10 power 8 meter per second. We know that. Yeah, see what I'm telling. The refractive index, it's the ratio of speed of light in some medium. Okay, it may be water, air, etc. Below that, we'll be dividing that with speed of light in vacuum. Ma'am, in which school and college you have studied? I have studied my schooling and college in Davangere in Karnataka, okay. From there, I am from Davangere. So I have studied there my schooling and college and all, right? Okay, let me come to here very quickly. So applications of spherical mirror, you may get this question for MCQ kind of question. 1 mark, 2 mark you'll get. So concentrate here. So concave mirror is a converging mirror. Yes, Rahul Kumar Yadav, yeah. So concave mirror is a converging mirror. What converging mirror means? It focuses all the light rays at a point. So when you are searching with a torchlight something, you want the light to be focused at that particular point, right? Yes, Tarun? Done? So see, you want the light to be focused at a point. So in concave mirror is used in torches, searchlight and vehicle headlights. So you want focused beam in front of you. But you will be using convex mirror in street lights, because in street lights you don't want a stationary light. Street lights want that area, that street should be covered with light, right? So in street lights we will be using convex mirror, and rear view of vehicles will be used by convex mirror. Why? You want to see the vehicles which are coming behind where you are driving, right? So when you use convex mirror, the image size will be diminished. When image size gets diminished, more vehicles can be captured on that image, on that mirror. So we'll be using that. Shaving mirror, dentist and solar furnace. In a shaving mirror and dentist, we want image size to be enlarged. So we use that. Coming here, security purpose, to cover the large area, we use convex mirror. Is this done? Quickly tell me. Do you want some explanation or shall we move? Yes. So we will be discussing some of the questions also. Shall I? Okay. Ma'am, in torch, lens are present or mirror? So in torches, so lenses will be present, but mirrors also will be there. We can see that combination, I think. Yeah? If it is convex, if you take the mirror out and if you can touch and see, you'll get to know that. Yeah. Shall we? Okay. Yes, before that, again, to solve your numericals, you want this formula. Without this formula, you can't solve the numerical problem from light chapter. So this formula, quickly, what is magnification? Magnification is the ratio of height of image by height of object. What's the formula? M is equal to, I'll write this as Hi by Ho is equals to minus V by U. And what's the mirror formula? 1 by V plus 1 by U is equals to 1 by F. Now tell me, how do you remember this negative minus sign? Tell me quickly. You just behead the formulas or do you have some trick here? Yeah, shall I give a trick? Shall I give a trick to remember this minus, negative? So listen, I'll not make you more wait for that numericals. I'll tell myself, see, we are discussing about mirror, right? Mirror starts from M. And also in that we are discussing about magnification. This M stands for mirror. This M stands for magnification. Okay, no, you don't have trick. So I have a trick here. You can follow this. Mirror, magnification. M and M gives M. What is that? Mirror, magnification, minus. Minus is nothing but negative. Geography will be taken care by Navya ma'am. Okay. Economics by Ankita ma'am. Okay. You don't worry about that. They will be taken care. It will be taken care. Okay. So teachers will be starting with that social SST fastly. Okay. Don't worry about that. Mirror formula. So, okay. Mirror, magnification, minus. Just remember that. Yum, yum, yum. Mirror, magnification, minus. That's all. And this is mirror formula comes before lens formula. So, mirror gets the priority of positive. Here, mirror formula. Here, magnification. Mirror, magnification, minus. Done with the formula? What's the formula? Let me recall once. Mirror formula is 1 by F is equals to 1 by U plus 1 by V. And magnification formula is HI by HO is equals to minus V by U. Yeah, they have done masters on science, but we can handle the 10th level social, right? Economics or your social studies. Yeah? 10th level can be handled, okay? It's not a problem. Shall we move further? Done with the formula? Yes. Okay. Yeah, moving forward. A question, a numerical which you were waiting. So you have the numerical question. Tell me the answer. Yes, numerical is on your screen. A student has focused the image. So, yeah, before telling you to answer, let me tell you how I answer this question. Okay, whenever I get a numerical, first my concentration, my focus will be on the question, because question will be giving us most of the hint. It will be giving us important data to solve the answer. So, while solving the numerical, first step you have to follow is concentrate on your question and extract the given data from that. Okay, let's do that. A student has focused the image of an object, height 3 centimeter. So what is given? Object height is given. First data, I'll write that. So what's given? Height of object, it's 3 centimeter. Okay, then on a white screen using a concave mirror of focal length 12 centimeter. Okay, so focal length is 12 centimeter. But which mirror? Which kind of mirror is this? This is a concave mirror. Yeah, minus 36 centimeter. Very fast. Yeah, let's see. So I was telling this. So concave always have a negative sign. So remember, concave lens or concave mirror. Okay, two different answers. Let's try out. Let's check what comes. Minus 7.2 and minus 36 centimeter. Okay, see here. Focal length of concave mirror or concave lens. The word concave. Okay, it means that focal length is negative. Fine. Moving forward, if the distance of object from the mirror, object distance, that is u will be always negative. So it's minus 18 centimeter. Yeah, find the value of the following. What is V and what is height of image? Okay, I have written the given data. Let's solve the problem. Sorry ma'am, it is 36. Okay, let's see. Yeah, so given data is ready. Now let's use mirror formula. Yeah, mirror formula is 1 by F is equals to 1 by V plus 1 by U. Yeah. So I'll substitute the terms. 1 by F is minus 12. and 1 by V, we have to calculate, plus 1 by U is minus 18. Okay, I'll write here. If I transfer this minus 18 here, it will become plus 18. Here it's minus 12 is equals to 1 by V. Okay. Let me solve this. Okay. 1 by V. Height of image minus 6 centimeter. Yeah. Let's see. So 1 by V is equals to, so yeah, LCM is 36. You have calculated it already. So 18, yeah, 36, 18 twos are minus 3. So it's minus 1 by 36. Absolutely right answer. V is equals to minus 36 centimeter. We have got the image distance to be minus 36 centimeter. You should write centimeter also. Why? If you will not write that in the examination, they'll cut the marks for that. Simply why we should cut our marks, right? So don't forget to write the SI units. Yeah, height of the image from magnification formula. Height of image by height of object is equals to minus V by U is the formula. We have to calculate height of image. What's height of object? 3 centimeter. Okay. Minus V is minus 36. And what about U? Minus 18. This minus it gets cancelled. Okay. So 18 ones are, 18 twos are, 3 twos are, 6 with a negative sign. Minus 6 centimeter is the height of image. Absolutely right answer. Okay. Keep doing good. Yeah, it's here there is no competition, there is no race going on, right? But you should practice, you should do well. So the answer is absolutely right. It's minus 36 centimeter and height of image is 6 centimeter. Yeah, shall I move? Okay. So yeah, okay, here the answer is displayed again. Minus 2. Yeah, magnification, we didn't calculated this magnification. We can calculate that too. It's not asked, but if we calculate it, it will be minus 2. And what is the SI unit of magnification? Quickly tell me. Tell me quickly. What is the SI unit of magnification? Yes. What's the SI unit of magnification? Quickly, I should move forward. No SI unit. Yes, no SI unit. Why? Magnification is minus. You can ignore that minus. Image distance is in centimeter. Object distance is in centimeter. Both will get cancelled and there will be no unit for magnification. Yeah. So this is not a numerical question, it's the theory based question, but it has been asked in 2011, 15 and 19, 3 times it has been repeated. So I have chosen this question. Yeah, Meenakshi. No, because ratio, yeah, when we take the ratio, it will be cancelled, hence it will not have any unit. Good, Meenakshi. Yeah, right, absolutely. So laws of reflection lists 4 characteristics of image formed by plane mirror. This is discussed by me in the beginning of this session, right? Yes, Tarun, ma'am, no SI unit because it's a ratio. Yeah, fine. Ratio, not because that, right. Yeah. Done, students. So no need to answer this again, right? We already know what are the laws of reflection. If you have any doubt, any confusion about this, you can just drag the video to the before. You'll get the answer and it's not too difficult also, right? Don't see these many texts and get confused. It's very easy. Okay, again a theoretical question. Yeah, Tarun, it's absolutely right. Yeah, Yes, Jillian. Yeah. Virtual and direct. Yeah. Properties. Fine. So we have discussed it in the beginning of the session. Ma'am, please teach refractive. Yeah, about refraction, the session will be discussed tomorrow. Okay. In today's session, I have discussed about reflection. In tomorrow's session, I will be discussing about refraction. In that, we will be discussing about refractive index also. Fine. Now tell me, what's pole? Define pole of spherical mirror. Quickly. What's the pole of spherical mirror? It's the center of the mirror is called as pole. Yeah, it's right. More answers you can tell. Yeah. Any more answers? Pole definition. Yes. Thank you, Meenakshi. If you are liking my teaching, I am very obliged. Thank you so much. Okay, no worries. Typing mistake. Nothing, no worries. Fine. Okay, shall I move forward? Right. So what's pole? There are multiple definitions for pole. Pole is the center of the spherical mirror. Yes, Meenakshi. So pole of the spherical mirror is defined as the geometric center of the spherical mirror, surface of the mirror. It's the center of reflecting surface. You can write this definition also. Okay, you can tell it's the center of reflecting surface, or it's the geometrical center of the sphere. Everything are right. Okay. Yeah, moving forward to the sixth question. So what's the sixth question? What is the magnification of image formed by plane mirror and why? Tell me the answer. What is the magnification of image formed by plane mirror and why? Yes, students. What is the magnification? Think about absolutely, it's 1. And why? Why, Jillian? Why, Junil? Yeah, sorry if I pronounced wrong. Because image. So what's magnification? Height of image by height of object, and both are equal. We have studied it in one of the properties of image formed by plane mirror, right? Yes, 1 because the size of image is same as the size of object. Yes, since the size of image formed by plane mirror is equal, yeah, absolutely. The magnification produced by plane mirror is +1. Yeah, okay, yeah. Good students, very well done. Yes, Tarun. Okay, very well done, students. Yeah, the magnification is equal to 1 because of our property, that is height of image. Image and object will be of same size, so they will get cancelled and we'll get here 1. Shall we move to the next question? Very well done, students, very well. Okay, your preparation is very, okay, it's with the boom, I hope. Yeah, so I wish you all the best for your examination. Everybody should score well. Okay, my name is Neha. Okay, you can find that on the channel. Okay, that video you can see the title also, it will be there. Okay, it's Neha, Neha, right? So let's move to the 7th question. Yeah, what's the 7th question? A concave mirror has focal length of 20 centimeter. Okay, it's a concave mirror. Observe here. Okay, then at what distance from the mirror should a 4 centimeter tall object, height of the object is 4 centimeter. Yeah, then so that it forms an image at 30 centimeter from the mirror. Okay, image distance they have given, okay? There's a twist in this question, so be careful, okay? I'm telling it, so you'll calculate and you'll tell the answer, but be careful, there's a twist here. Please wish me to become doctor. Meenakshi, you will become doctor, okay? Don't worry about that. Just study hard. Just push yourself. Study hard, okay? Rest, you will achieve, okay? All the best. My wishes are always with my students, okay? Whatever your high aims, goals are there, just go and achieve that. Okay. So, yeah, the answer, Janil, u is equal to minus 60. Yeah, but the question is, so let me write down. Let me write what they have given. Focal length, it's minus 20 centimeter and 4 centimeter is the, at what distance from, yeah, it's object distance, 4 centimeter. Then image distance, V is equals to 30 centimeter. What they have asked? Also calculate the size of image, okay? They have asked U and height of image. Yeah, what Meenakshi, what you have written? Madhu Mitra. Yes? Okay. Your name. Okay, Madhu. Okay, Madhu, I'll really wish, I want you to become doctor, okay? Yeah, Tarun, Junil are writing the answers. We'll calculate for that. The object should be placed at 60 centimeter towards focus. Okay, fine. Yeah, Madhu, I wish you all the best to become doctor, okay? Study hard, that's all. So, see here, what's the catch is, they have not given where the image is formed. Okay, you cannot take this simply 30 centimeter, right? Because the catch here is, it may be in the first condition, you can consider it to be 30 centimeter, but in second condition, we have to consider it to be minus 30 centimeter. Why? Because they have not specified us. So, where is the image? Thank you, welcome. Okay, getting my point. Junil and Tarun, you have written the answer, no. But see, they have not specified that image is formed in front of mirror or behind the mirror. Right? So, we have to calculate for both of the condition. Yeah, U is equal to 60, Martina Sharma, okay. So, calculate for both of them. I'll check out U is equal to 60 or minus 60. I'll check that. Okay. So, coming to the mirror formula, 1 by F is equals to 1 by V plus 1 by U. Okay. What's the F? It's minus 20. Okay. Then U is 30, 1 by 30 plus 1 by U. Okay, let me consider it to be minus first, okay? In the first condition, I'll calculate negative and second condition, I'll calculate positive. So that you will also get the time. Okay. Then, I'll take this, I wrote this minus, no. When it comes here, it's plus 30 minus 20 is equals to 1 by U. So, U is equals to, LCM is 60, 2 minus 3, yeah, it's minus 6, minus 1 by 60. So, in the first condition, V is equals to minus 60 centimeter. So, yes, it's minus 60. Ma'am, H1 is smaller than H2, so it cannot be virtual. But Hi is not given, right? We have to calculate that. So I'll calculate magnification. Let's direct. Shall I use direct formula here? Again, no necessary to write magnification and all, right? Second case, minus 1.2. What is minus 1.2? So I'll just take the height of image here. Height of object, it's 4 into minus v. Minus gets, okay, it's here not minus, no? Minus into minus plus. Okay, so I'm directly doing this. If you are unable to understand this, you can ask. Yeah, it's 6 centimeter. Okay, what's the mistake? Why you guys got 2? Height of image 2. It's 30. 31s are 32s are. Height of, okay, height of image. Yeah. Why it was 2? Can you tell me? Is this fine? 2, okay. 2 minus 3 minus 1 by 60. So here it's 60. Here it's 30, right? Okay. So this is V, right, sorry. That's a mistake. We have to calculate U. This is U and here it will be reciprocal. Okay, done. We have calculated U and what is V? V is 30 and U is 60. This minus gets cancelled. Yeah, fine. I got the point. 2 ones are, so it's 2 centimeter. Absolutely right answer. I just interchanged it to be, I thought it's V because always they ask in the question as to calculate image distance, right? Hi Yadav, hi. Okay, so always in the examination they'll be asking what is the image distance. So I wrote here V instead of U. That was my mistake. So height of image is absolutely right. It's 2 centimeter. 4 into 2, 6. Yeah, I thought that is V. That's my mistake. Yeah, it's not V, it's U. They may trick us like this. We'll be always in the mind, they'll be asking V, and suddenly they'll ask what is object distance. We should be careful. Okay, coming to here. So negative is done. Okay, yeah. Negative is done. Now positive. Shall I erase this slide? Here there is no place to solve. Shall I erase the slide? Done. Here there is no space to solve more. Okay, I'll be erasing this. Done. Ma'am, how 2 into 4 can be 6? I think I have added it. Sorry, Janil. When it will be fast. When we will do, no. Somewhat it happens. Shall I erase this now? Now I will be considering positive 30. Yes, tell me quickly, shall I erase? Hi quiz master, hi. You should, okay, if you join early, you can stay with the session, you can enjoy, you can learn, it will be great, okay? Join the sessions early. Now we are done with the session, it's almost done. Ma'am, please explain sign convention through Cartesian plane once. Okay? Thoda Hindi bhi boliye, ma'am. Okay, there's no problem Hindi bolne mein, but this channel is specifically for, okay, if you have any doubt specifically anywhere, you can ask me in Hindi for that. Yeah? I'll be teaching in English. If you have any doubt anywhere, you can ask me, tell me this in Hindi. I can do that. Ma'am, is there any session after yours? I hope, I don't know about that. I don't think there are today. If there will be sessions, it will be priorly uploaded in the channel. You will get to know that. I don't think so. Yeah. The sign convention which you wanted to know. Yeah. Results. So see here. Let me quickly tell you. Okay. Yeah, let me take to that slide quickly. Yeah, 1 second. Where was the sign convention? Yeah, see, see this sign convention. To remember these all things, you have to remember this Cartesian plane I said. So what is this Cartesian plane? Yeah, we have Ankita ma'am. Okay, Ankita ma'am session is, yeah, I forgot, I think. Sorry, I didn't check it out. Is it posted? If it is posted, Ankita ma'am will be taking the session, okay? Yeah, Ankita ma'am has session today. Yes, sorry for that. So, yeah, ma'am is there. Yeah, okay. So, see here, I'll tell this first, okay? Then I'll be answering your question. What is Cartesian? Don't you have this graph in your 10th standard? Tell me first, quickly. Don't you have this graphical in your high school? I hope you have, right? Quickly tell me, you have seen that? Not posted? Yeah, maybe ma'am will be taking, I think, Ankita ma'am sessions. Yeah, maybe ma'am take today. Okay, so tell me quickly, you have seen this kind of graph in your maths or not? You have the graph, right? You have, right? So similarly, you know that maths graph, no? Just use that for your physics. Instead of origin, we call it pole. Okay, we have, yeah, done students. So instead of your origin, we'll call here pole. And you know, anything that goes towards this right, we call it as positive x-axis. Okay, anything that goes towards right, we call it as positive x-axis in mathematics. In physics, it is posted. Okay, fine. In physics, if you are measuring, consider here a image is formed. Getting my point? Where? In the right side of the graph. Here. Okay, here a image. Here a image is formed. Okay, you are moving this word direction. This is your positive x-axis. Right? So, here this image distance V will be positive. If the image is here towards the left, it is negative y-axis. Sorry, negative x-axis. So, here the V will be minus V. So, that's all. And if the image is upright, it is positive. Height of image you will get positive. If it is inverted, you will get negative. That's all. No more questions, no more doubt, I hope. So see, this is, if I consider this to be object, it's moving towards left, okay? Always the distance should be measured from the pole. Keep this point in your mind, okay? Always, every distance should be measured from the pole. So from the pole, I am moving towards left. So here, the object distance will be negative. That's all. Is it clear now? Okay, cool. Good then. Yeah, coming to our question. Okay, coming to our question. Let's solve it for plus 30. Let me erase this. I'll consider this plus 30 here. Okay. So this is plus. Here it will be minus. And rest things will be calculated. Okay, calculate this. Tell me the answer. If we consider V to be plus 30, what will be the answer? Okay, minus, minus. So 1 by U will be equal to 60 LCM. So this is minus 2, minus 3. Right? Tell me the answer quickly. I'm going to write the answer. Before that, you should tell the answer. So what will be U? This is minus 5 by 60. When you reciprocal that, you'll get minus 60 by 5. 5. What's 12 5s are? Yes? u is equal to, it's not 60, it was 60 when we took this minus v, right? Now it's positive, so it's minus 12 centimeter, right? So we got, minus 12. Janil, Tarun, centimeter you have written now. Tarun and Rizal, you have not written centimeter. Just remember that while writing your exam, okay? There you can't miss that. Okay, now height. What's the height of image, right? Height of image is equal to height of object 4 into, here we have a negative sign, v. So v is 30 and here is minus 12. So minus minus cancel. It's 4 ones are, 4 threes are, right? 3 ones are, 3 tens are. So what's the height of image? Height of image, not, it's calculated. No, it's not. That's good. Height of image you haven't calculated yet. What is the meaning of Ugram in this series? It's Abhijit, okay. So Ugram means it's like rigorous. We are very near to our examination, right? You have your examination very near, right? So we should be not, it's not easy going, it's like rigid, it's like straightforward, energetic, Ugram. It means that rigorously you're preparing for your examination. Yeah? Okay. I haven't, Junil has given 10. And Tarun has also given the answer 10. That is the height of image. Now tell me the SI unit of height of image. It will have centimeter, right? Tarun, why all your answers? Why? It's nothing. It's okay. It's fine. It's fine. See, listen. If you do any mistakes here also, it's all fine. Because you are learning here, right? So you are not wasting your time. You are learning here. You are improving yourself. So finally you'll score well. It's centimeter. Yeah. So remember that. Okay? Centimeter. Yes. Very good, students. So here we have solved 7 questions as I said before of this session. Now tell me quickly, how was today's session? Did you guys enjoy today's session? Did you learn? How was the session? Tell me quickly. I'm very curious to know that. My 10% was 86% to be frank. 86. Then in again graduation I scored well. So it will be roller coaster ride. Fine. Okay. So study well, score well. Full masti. Okay. Yeah. How was the session? Maze hi maze. Okay. Shivansh, right? Yeah. How was the session? Yes, tell me. We are done with today's session. Did you guys learn? Did you guys like this session? Must. Okay. Great. Great then. So today your reflection, okay? Adbhut. And what is that? Adhivesan. Okay. Okay, it was so extraordinary. Fine. Okay, students. So study well. No. Full fun and enjoy. Yes, that's the Josh. Let's keep that Josh. No. Mama, the timing for science sessions, I'll be regular. Yeah. The time is given or it will be given, I think. Is the time still not posted? Quiz master, no, I'm not ignoring you. No, I hope I didn't saw that time. My mother tongue. Ma'am, your mother tongue, it's Konkani. No, quiz master, I'm not ignoring you. I don't want to ignore my students. Okay? Don't think that. Sorry, I missed that, I think. So sorry for that. Yes. Okay. So this session of today we have completed, okay? You're new here, okay? If you're new, subscribe the channel. Hindi, this channel is specifically for English. Okay, if you want somewhere, if you want Hindi, I can explain you with that Hindi. Okay, no worries. Chill. Okay, ma'am, quiz master. Done. I'm not ignoring you, right? So yes, students, we are done with today's session. We have completed the reflection part. Yay! Okay. In tomorrow's session, okay, I'll see that. Okay. After we'll be having marathon. No. After marathon, if time permits, I'll take refraction. Yeah, done. So yes, those who are new to this channel, lens, refraction, refractive index, that all concepts will be discussed in tomorrow's session. Okay, thank you so much, students, for so much of love and support. So keep learning, keep scoring well. Okay, those who haven't subscribed the channel yet, just go and subscribe the channel. If you like this video, hit the like button and share these videos with your friends so that they can also join and learn with us. Okay, so yeah, thank you so much for watching today's session, and let's meet again in the next session. Thank you so much. Bye bye.